This is the second recording for Chapter 5a, Applications of Arithmetic Sequences. This time we're going to use sequence theory on depreciation and two kinds of depreciation, which I will explain shortly: flat rate depreciation and unit cost depreciation. In both cases we're going to use the recurrence relation you're already now familiar with. Well, it's one minor difference. Now this time V0 is the principal, Vn plus 1 equals Vn minus d, because you're going to start with a certain amount and then it's going to go down in steps. Depreciation is an important business process. Depreciation of assets owned by the business, things which you buy to run the business, like cars, machines, photocopiers, tools. They all lose value over time, and that's what we mean by depreciation. And they depreciate in various ways. Some of them depreciate just by the passage of time. Others depreciate according to how much you use them. And so a business needs to be able to calculate the future value of a product, an asset, at any particular time. They also need to be able to estimate its scrap value when it's reached a certain period of time and they want to sell it or write it off for scrap. And perhaps more importantly, there are quite significant tax benefits to be gained from depreciating your assets through the tax office after you have purchased them. Taking the example of a car, a business buys a car for $24,000. You decide, because it's going to be used fairly regularly, that it's going to lose value at $3,000 a year. Now that is an example of flat rate depreciation, the rate being $3,000 a year, and it doesn't change year by year. So what will its value be after 3 years? Well, I've done the writing on the screen already. V0 equals 24,000. Vn plus 1 is Vn minus 3,000. So after 3 years, V1 is 21,000, V2 is 18,000, and V3 is 15,000. So that's what we call flat rate depreciation. More a question of getting familiar with the language of the application. The maths is still the same as it was. This is an example of unit cost depreciation. Basically, some machines, the more you use them, or the faster you use them, should I say, the quicker they will deteriorate. So you can buy a photocopier costing $7,000, and it loses value of $1,000 not each year, but for each 10,000 copies printed. So if you do 60,000 copies in 3 weeks, then you're going to find it depreciating quite fast. Anyway, what is its depreciated value after 60,000 copies? Well, V0 is 7,000 again. Vn plus 1 equals Vn minus 1,000 still, so nothing different there. V6 will be $654,321,000. Doesn't say anything about time, it just says after 10,000 copies printed. So in summary, quite a simple introduction here. We've used the recurrence relation for flat rate depreciation and unit cost depreciation. V0 is the principal, Vn plus 1 equals Vn minus d.